Welcome back to my YouTube channel. I appreciate you so much. Today, we are going to be talking on chemical symbols, chemical formulae, and valency. Without the understanding of these basic topics, chemistry will be seen as a mystical, boring subject, which is not the case. So stay tuned. I'll be right back. We normally know that a symbol is a representation of something, which can either be in the form of a diagram, a picture, or letters. In chemistry, we use one or two letters to represent elements. These letters are known as chemical symbols. These chemical symbols are taken from either the English name of the element, the Greek name of the element, or the Latin name of the element. These letters are either taken as the first letter of the name of the element, the first two letters of the name of the element, or the first letter and another letter. But in whatever case, if one letter is chosen, it is written as a capital letter to represent the chemical symbol of an element or a chemical element. If two letters are used, only the first letter is written as a capital letter. So which means that if letter H is chosen as the chemical symbol of an element, it will be written as capital H. And if O is chosen, it will be written as capital O. If it is C, capital C. If it is two letters NA, only N will be written as a capital letter. If it is MG, only the M will be written as a capital letter. If it is CL, only the C will be written as a capital letter. And if it is CA, only the C will be written as a capital letter. So the A here, G here, L here, and this other A are written as small letters because they appear as the second letter in the two letters that have been chosen to represent the chemical symbol of an element. So all of these are called chemical symbols. Now, how do we define a chemical symbol? Just by looking at what we have here, we'll define a chemical symbol as one or two letters used to represent an element. There are other situations where we might have two or more chemical symbols being used to represent another symbol. So in this situation, we call it chemical formulae. So which means that when two or more of the chemical symbols are used to represent another symbol, we call it a chemical formula. Many of them we call chemical formulae. So you can see that in H2O, we have H that is being used to represent a chemical symbol of an element, and O, which is also used to represent the chemical symbol of an element. Another symbol which is called chemical formula, and many we call them chemical formulae. So there are some situations where we might have just two of them, and in another situation we might have more than two of them. Now looking at what I have here on the right, H2O is called water, CO2 is called carbon dioxide, NaCl is called sodium chloride, Mg bracket OH bracket 2 is called magnesium hydroxide, CaCO3 is called calcium carbonate, and Al2O3 is called aluminum oxide. Now, water, carbon dioxide, sodium chloride, magnesium hydroxide, calcium carbonate, and aluminum oxide. How do we call them? We call all of these compounds. So you can see that I'm talking about elements and compound here, which I discussed in this my video. So you can click it to watch before this one. Now, looking at these compounds, you will see that the space they occupy is larger than the one occupied by chemical formulae. So how then can we define a chemical formula? Looking at what we have here, you see that a chemical formula is the short way of writing the name of a compound. Now, looking at this chemical formulae, you will see that we have also used numbers. In the first case, we have used 2. The second case, we have also used 2. In the fourth case, we have also used 2. Fifth case, we have used 3. And in the last case, we have used 2 and 3. So how then do we call these numbers? We call them valencies. These numbers are considered as the powers which the chemical symbols use to combine with other chemical symbols to form chemical formulae. So we can define valency as the combining number or power of an atom of an element or group of atoms. Now, when we talk about atom of an element, what do we mean? In the case of water, this H here is an atom. O is also an atom. And for this case, Mg is an atom. But OH, which is in bracket, is a group of atoms. And if you consider this other case, CO3 is also a group of atoms. So which means that to have a chemical formula, there are two things which come together. So we can either have two chemical symbols coming together to form a chemical formula, or we can have a chemical symbol and a group of atoms to form or to have a chemical formula. So how then do we write a chemical formula? In this video, we are going to consider the first 20 elements. We have numbers here labeled as atomic number from 1 to 10, and on this other side from 11 to 20. For you to easily write them in order, you have to form a song, or you can follow this one. The song goes as follows. Hey, he little better boy, come near our field. New nation manufacture all silver pots. So could Africa know Cameroon. I repeat. Hey, he little better boy, come near our field. New nation manufacture all silver pots. So could Africa know Cameroon. So now, by singing the song, you'll be able to identify the chemical symbols of the elements. So which means that in here, we take H as a chemical symbol, He, He as a chemical symbol, little, Li as a chemical symbol, beta, Be, boy, B, come, C, near, N, O, field, F, new, Ne, nation, Na, manufacture, Mg, all, Al, silver, Si, pot, P, so, S, could, Cl, Africa, Ar, no, K, and Cameroon, Ca. So it means that after singing the song, you should be able to identify the letters that are used to represent the chemical symbols of elements. After identifying the chemical symbols of the elements, the names given to them are H for hydrogen, He for helium, Li for lithium, Be for beryllium, B for boron, C for carbon, N for nitrogen, O for oxygen, F for fluorine, Ne neon, Na for sodium, Mg for magnesium, Al for aluminium, Si for silicon, P for phosphorus, S for sulfur, Cl for chlorine, Ar for argon, K for potassium, Ca for calcium. Now you realize that for sodium and potassium, the chemical symbol is taken from the Latin or Greek name, natrium and kalium respectively. And again, you will observe that the chemical symbols are taken from either the element's name, like in the case of hydrogen, H, the first two letters, like in the case of helium, He, and the first letter and another letter, like in the case of magnesium, and so on. So if you understand this, you will have no stress when writing the chemical symbols of elements. So these symbols are the internationally accepted symbols for the different chemical elements. Now, after singing the song in that order, you'll be able to know the corresponding valencies of the different elements. Now, for example, if you sing the song and you reach at nation, nation is number 11. How then do you know the valency? You start from 1. After 1, you go to 0. 0 to 1, 2, 3. Until when you reach 4, you start reducing. 3, 2, 1, 0, 1, 2, 3, 4, 3, 2, 1. So after counting, the number that reaches at nation will be the valency of that element. Or you can also use your fingers. For example, if we have element number 10, what are we going to do to know the valency? We'll just say 1, 0, 1, 2, 3, 4, 3, 2, 1, 0, which means that the 10th element has a valency of 0. Now, this is done without you looking on the table. Now, to confirm, you realize that the 10th element here has a valency of 0. So, this is what you can do in order to know the valencies of the different elements without you even referring to this table. So, all what you need to do is just sing your song in that order. You end at a particular number. That particular number will tell you the chemical symbol which you will use to identify the name of the element. Now, at that point, you have a particular number. You start counting 1, 0, 1, 2, 3, 4, right up to that particular element or that particular number. The number that reaches you there be the valency of the element. Now, we define valency talking about group of atoms, which means that group of atoms also have their valencies, as we are going to see. The group of atoms that we will usually come across when writing the chemical formula of compounds will be OH, NO3, NH4, CO3, SO4, and PO4. Now, if you see OH, it means it is hydroxide. If you see NO3, it means it is nitrate. If you see NH4, it means it is ammonium. If you see CO3, it means it is carbonate. If you see SO4, it means that it is sulfate. If you see PO4, it means that it is phosphate. Now, in the reverse case, if you see hydroxide, know that the group of atoms will be OH. If you see nitrate, it will be NO3 and so on. Now, what are their valencies? We have 1 for hydroxide. We also have 1 for nitrate, 1 for ammonium, 2 for carbonate, 2 for sulfate, and 3 for phosphate. If you cannot easily remember these valencies, You can do that using a simple trick. Now, in the case of OH, we know that the valency of oxygen is 2 and that of hydrogen is 1. So what do we do here? We subtract the smaller number from the bigger one. The result will be the valency of the group of atoms. So in this case, 2 take away 1 is 1. For NO3, we will consider 5 for nitrogen. Now, for oxygen, we know that it is 2. 2 times 3 is 6. So 6 take away 5 is equals to 1. We go to the next, NH4. We know that 5 for nitrogen, and for hydrogen, we know that it is 1. So 1 times 4 is 4. 5 take away 4 equals to 1. Also for CO3, we know that the valency of carbon is 4. That of oxygen is 2 times 3, 6. So 6 take away 4 is equals to 2. For SO4, we will consider 6 for sulfur. Now we know that for oxygen it is 2. So 2 times 4, we have 8. 8 take away 6 is equals to 2. And for PO4, we'll also consider 5 for phosphorus. So we know that the valency of oxygen is 2. 2 times 4, 8. Now 8 take away 5 is 3. So if you cannot remember this table, you can use this simple trick to know the valencies of the group of atoms. So now we are ready to write the chemical formulae of compounds. So far, we now know the chemical symbols of the different elements and their corresponding valencies. And we also know the chemical symbols which function as group of atoms and their corresponding valencies. So we are now set to write the chemical formulae of compounds. However, in order for you to write the chemical formulae of a compound, there are 3 basic rules that you are supposed to respect. The first rule says, write the correct symbols of the elements or group of atoms. The next rule says, write the correct valency below each symbol. And the third rule says, exchange the valencies and write them as subscripts. Simplify if possible to get the correct chemical formula. So examples, write the chemical formulae of the following compounds. The first example here is sodium chloride. How do we write sodium chloride? We follow the first rule that says the correct symbol of the element. The correct symbol of sodium is Na from nation. Chloride is coming from chlorine. So the correct symbol of chlorine is Cl from cold. Now, what's the valency of sodium? If you sing the song, you will realize that nation is at number 11. Now, counting 1, 0, 1, 2, 3, 4, 3, 2, 1, 0, 1. You see that you arrive 11 at 1. So the valency of sodium is 1. That of chlorine, if you do the same thing, you are going to realize that cold is at number 17. Now, if you count 1, 0, 1, 2, 3, 4, 3, 2, 1, 0, 1, 2, 3, right up to number 17, you are going to end at 1. So the valency of chlorine is also 1. Now, the next rule says exchange the valencies and write them as subscripts. Before exchanging, we write down the symbols. So this will go here, and this will also go here. Now we expect that the chemical formula should be Na1Cl1. But in chemistry, we don't include 1 when writing the chemical formula of a compound. So the chemical formula is simplified as NaCl. NaCl. Now, what do you realize here? You realize that when writing the chemical formula, you don't give space between the symbols. So what we do here on the right is just a procedure to help derive the correct chemical formula of a given compound. Now, the next compound that we have is sodium hydroxide. Without wasting time, we know that for sodium is capital N small a. For hydroxide, we know that hydroxide is a group of atoms OH, a group of atoms containing oxygen and hydrogen. Now, what's the valency of sodium? Without wasting time, it's 1. That of hydroxide, if you have forgotten the table, you can just remember the trick that since the valency of oxygen is 2 and that of hydrogen is 1, 2 take away 1 is 1. Now, we bring down the symbols and then interchange or exchange the valencies. Because OH is a group of atoms, we put it in brackets. Now, if we interchange, this will be 1. We interchange here, also have 1. So we expect that the chemical formula should be Na bracket OH bracket 1. And now, since we don't include 1 when writing chemical formulae, so we'll say that the chemical formula of sodium hydroxide is NaOH. NaOH. We go to the next. The next compound is magnesium hydroxide. For magnesium hydroxide, we know that we have Mg from manufacture. Hydroxide, without wasting time, we know that it is OH. The valency of magnesium is just after nation. If we can have 1 as the valency of sodium, then automatically the valency of magnesium is 2. That of hydroxide, without wasting time, we know that it is 1. Now we exchange. Before exchanging, we bring down the symbols. Since OH is a group of atoms, we put it in bracket. And then we exchange the valencies. So we expect that the formula should be Mg1 bracket OH bracket 2. Now, since we don't include 1 when writing chemical formulae, this chemical formula is simplified as Mg bracket OH bracket 2. So what about aluminum oxide? We know that aluminum is Al from all, oxide is from oxygen, O from R. The valency of aluminum, all is just after manufacture. So if for magnesium we have 2, for aluminum will be 3. For oxygen, we know that it is 2. Now, to write the correct formula, we bring down the symbols and interchange or exchange the valencies. Here we have 2 and here we have 3 and write them as subscripts. So expect that the formula should be Al2O3. Now looking at this, there is no way that we can further simplify this formula. So the chemical formula of aluminum oxide is Al2O3. Okay, we go to the next compound, calcium carbonate. The correct symbol of calcium is capital C, small a. That of carbonate is CO3. Remember calcium for Cameroon, and Cameroon is at number 20, in which we ended the valencies with the number 2. Now for carbonate, if you cannot remember the table, we know that the valency of carbon is 4, that of oxygen is 2. 2 times 3 gives you 6. 6 take away 4, 2. So the correct chemical formula is, we bring down the chemical symbols. Since CO3 is a group of atoms, put it in brackets. Then now we exchange the valencies. So we expect that the formula should be Ca2 bracket CO3 bracket 2. Now we can further simplify. 2 here is 1, 2 here is 1. And we don't include 1 when writing chemical formula of compounds. So this formula is simplified to CaCO3. CaCO3. Now we go to the next. The next is potassium, or we can say potassium sulfate. For potassium, we know that K from no, sulfate SO4. Now, the valency no is at 19. If that of 20 calcium is 2, then that of 19 potassium should be 1. For SO4, we said we give 6 to sulfur. And since we know that it is 2 for oxygen, 2 times 4 is 8. 8 take away 6, we have 2. So bring down the symbols before exchanging the valencies. Now, since this one is a group of atoms, we put it in brackets. So here we have 2, and here we have 1. So we expect that the chemical formula should be K2 bracket SO4 bracket 1. Since we don't include 1 when writing chemical formulae, this formula is further simplified to K2 SO4. K2 SO4. For ammonium nitrate, we know that ammonium is NH4, nitrate is NO3. The valency of ammonium is 1. If you have forgotten, we said we give 5 to nitrogen. We know that the valency of hydrogen is 1. 1 times 4 is 4. Now 5 take away 4 is 1. Again here, we know that 5 for nitrogen, 2 for oxygen. 2 times 3 is 6. 6 take away 5, 1. So we bring down the symbols and put in bracket because it's a group of atoms. We do same for nitrate and then interchange the valencies. Here we'll have 1 and here we'll have 1. So we expect that the formula should be NH4 bracket 1, NO3 bracket 1. So since we don't include 1 when writing chemical formulae, we'll have NH4 NO3. Now the next compound is ammonium sulfate. So in ammonium sulfate, we know that ammonium is NH4, and sulfate is SO4. Without wasting time, we have already seen that the valency of ammonium is 1 and that of sulfate is 2. So before interchanging or exchanging the valencies, we bring down the symbols. And since it is a group of atoms, we put them in brackets. Before interchanging the valencies. So here we have 1, here we have 2. We expect that the chemical formula should be NH4 bracket 2 bracket SO4 bracket 1. Now, since we don't include 1 when writing chemical formulae, this formula is simplified to NH4 all bracket 2 SO4. NH4 all bracket 2 SO4. Now, for example 9, this is a special case. We have carbon monoxide, which can also be called carbon 2 oxide. So take note of this particular situation. Whenever you see the name of a compound written like this, and you see in bracket Roman numeral, that number inside the bracket is the valency that the element has used to combine with the other element. Which means that in this situation, carbon, instead of using the valency for which we already know, it is using the valency of 2 here to combine with oxygen. So to write the chemical formula, we know that C for carbon, O for oxygen. Now they have told us that carbon 2, which means that the valency of carbon here is 2, and for oxygen we usually know that it is 2. Now before writing the chemical formula, we bring down the symbols and then interchange or exchange the valencies and write them as subscripts. So expect this to be C2O2. Now we can further simplify 2 here 1, 2 here 1, which means that the chemical formula of carbon 2 oxide is CO, which we also call carbon monoxide. So you use the knowledge which you have acquired from this video to answer question 10, 11, and 12, and leave your answer in the comment section. We'll discuss about it. We'll end this video here. You'll realize that in the course of this video, we have seen how the chemical symbols of the elements are gotten from their English names, Greek names, or Latin names. We have also seen that in the case of the first 20 elements, if we form a song, that song will help us to identify the chemical symbols of the first 20 elements. Now, from the chemical symbols, we can also identify the names of the elements. Now, the order in which you sing the song also helps you to know the corresponding valencies of the different elements. So we have also seen that there are some group of atoms that function as a single unit. Now, to know their valencies, you just have to subtract the smaller number from the bigger one. So now, knowing the chemical symbols of the elements and their corresponding valencies, we have used them to write the chemical formulae of compounds. So in another situation, they can give you a chemical formula for you to write the name of the compound. So in whatever case, once you have already known how to write or derive the chemical formula of a compound, it will be easier for you to write the name of the compound. Don't also forget that there are some elements which use more than one valency to combine with other elements. So in that situation, the valency will be indicated in brackets in Roman numerals. So the number that you see in the Roman numeral will be the valency which the element has used to combine with the other element. So thank you for watching this video. If you like this video, give it a thumbs up, share it. If you are not subscribed to my channel, please subscribe to my YouTube channel. This will help me to upload more videos. And in my next video, I'm going to be talking on chemical reactions and chemical equations. So thank you. I will see you in my next video.